Alright, we finished all of the rough work, the work that isn't too critical with this. We've milled out this recess. This is just for clearance in the back so my tools can go down further, closer to the part. The part's going to be, of course, right here. And I just want clearance for the collet chuck so I don't have to hang the end mill out so far. That's the reason for this step in the fixture here. So we're going to mill this other side now. Now everything becomes critical from this point on. I'm going to mill a recess in this face that goes down 3/16 of an inch below the center line because the part's 3/8 of an inch thick. So we got to make sure that's very precise, within 1/1000th of an inch if possible. And then we got to put some locating holes, some screw holes to clamp the part down, and some screw holes and a slot for this clamp that's going to go here. This clamp right here is going to go somewhat like this here, and it's going to clamp inside the slot in the material. There's a slot in the edge and it's going to hold it down there. And then there's going to be some screws that go around the perimeter here that hold it down, and a couple of dowel pin holes. And all this has to be done fairly precisely now from this point on this fixture. Everything else is just the rough fixture, and now these are the locating surfaces we're going to do next on here. Just the roughing pass here by itself. That way when I start the real program that finishes this all up, I don't have to keep restarting it, because I may need to run the finish pass of this a couple of times to get it to the exact depth that I want. I want to be very careful with this, how to get it to the depth. So it's a little bit hard to check the depth here because you have nothing to check it in relation to except maybe this. So this is what this tail center, I'm figuring that this tail center is running on center of rotation, which it almost has to if it's going to be a center, right? And I mic the diameter of this with this mic, just so I know it for sure. And it comes out to 2.495 diameter, and you divide that by 2, we're coming out to 1.2475 for the height above center line, right at the top of this live center. So what I did was I put the Haimer probe, bringing it down here in the x-axis, I put it in the spindle, and this is touched off or calibrated to a specific length, so I can actually measure with this thing, kind of like if I had a Renishaw probe, but I don't want to mount it all and do all the measurement. I'll just do it here manually with this thing. So if I bring that to 0, then over here, I'm going to pick up the camera here, so it's going to be kind of shaky. On the display, get the reflection out of here. This is 1.2475, which is, so that's measuring exactly the right height when it's touching that. So let me bring the probe over to here, jog it up, and we'll see where we are. Now this should be, I'm going to move the camera over here a little bit more. Okay, we're going to jog over here somewhere on that surface. I'm just going to stay on center line right now just to see where I'm at. I'm going to come down on here and get the camera a little closer here. So I'm going to jog this down to 0 on the probe. Just right there. And this height, this rough height, should be 10 thousandths too high if everything is right. But this is why I want to check it, because I want to make sure. You can't depend on anything being exactly where you want it without checking it. Even though ideally it should be there. I think my my pocket is about 2 thousandths higher than normal. I made it that way on purpose so that I'd have something to work with it if I needed it. Let's check to see what the display is saying over on the machine right now, because this should be, we just kind of calibrated the probe and it should be pretty accurate. And so we're at minus 1.1735. So that if we're going to 0.1875, we're just a little bit short of the 10 thousandths. So we got to go a little bit deeper than 10 thousandths. But what I'm going to do is I'm going to run it anyway, because I want to be careful here and see. I should come to 0.1835. That should be just a little bit more to go if everything is right on this milling cycle. I just want to be careful here. I don't want to go beyond it. So it'd be better to be short and have to take another cut. And it takes about I don't know, 15 minutes to run this finish pass, and it's better to be safe than sorry. So let me jog this around. I don't like using a Haimer indicator like this, but I just want to see if we're roughly gotta be careful. I don't want to hit that indicator on the side. We're roughly straight here. It should be. The machine machined it just a minute ago. Looking pretty good. Let's go all the way down to the end. Don't really, like I said, I don't really like using a Haimer probe this way, because I don't think it's really designed to sweep things like a last word indicator. But just for the purpose of checking this right now, just to make sure we're straight. And the reason I left this to last, okay, because I didn't want to, I don't know if you can see that. I didn't want to machine this first, of course, and then rough out that big hole through the middle and then have everything move on me, like the thing would warp or something. So I wanted to machine everything, put the side stiffeners on here, bolt them down, cut out this big hole in the middle, and then machine this very last. And of course the little holes for the screws won't cause distortion. But the piece of material is going to set on here, and this is important. This is the thing that's critical for this fixture to function properly. So now I'm going to run the finish pass on the face here. That should take it down 10 more thousandths, and we're going to check it again. see where we're at. All right, what we're shooting for is 0.1875. And let's see where we're at here. We're at 0.1836. So we got a little bit more to go to get to the 0.1875. Let me jog this around a little bit, make sure I'm still straight. Doesn't look too bad. All right. So 0.1875 minus 0.1836 is going to be, so I don't make a mistake here, 0.1875 minus 0.1836, right? Yeah. Equals, so we got to go down 3.9 thousandths. Oop, I don't know if you can see that, the reflection. Light's bad here. Anyway, we got to go 3.9 thousandths deeper. I'm going to just change the offset of the tool for this. Although my actual profile was programmed 2 thousandths high just to be safe. And so I'm going to change the offset of the tool, but I'm going to back the tool back up after I cut this. I'm going to rerun this whole thing. I'm not going to film that because it's just the same as what you just saw. So I'm just going to rerun it. I just sprayed WD-40 on it before so you could see it, but I can rerun it with coolant running this time. I'm not going to be filming it. So let me change this offset. Tool data, and it's tool 16, I think. Oh, I got 16 out of the I got 80 in the spindle right now, but I know it's tool 16, which is this tool right here. And I'm going to go minus 0.0039 here. Input. It should change just a little bit. All right, so that should be the change I need to rerun this, and then I'll rerun it. And I'm not gonna, like I said, I'm not gonna record that because it's the same as what you already saw. Bring the indicator up to 0. About right there. It looks pretty good. Let's see what it looks like on the display, on the machine. Exactly right on the money. Perfect. Looks pretty good. Make sure I go all the way around here. I mean, to go around this steady rest base here. Be a little bit different right there. Might be running up on some shavings though. Didn't really clean this off very good. Not too bad. That's where it falls off the fixture. The material doesn't even set on anything out here anyway, so that's pretty good. I think I'm happy with that. All right, I screwed the aluminum setup piece on the fixture here. You can kind of see it mounted on here, and how I'm going to be able to get to the back side in here and machine the part on this side and also on the other side all at the same time. And then what I'll do is I'll cut it out with tabs along the profile here. And here's where the 1/4 inch dowel pin here and over here that line up the material from the previous operation on the horizontal mill. This is that long clamp that clamps. There's I don't know, you can't really see it, but there's a slot milled in the edge of the part, and this clamp goes up in there and it's holding it down to the fixture. This part of the part is the 3/8 of an inch thick, and the rest of it gets milled thinner, even thinner yet. Can't really go into anything about what the part is or what it does or anything else. And this is as far as I can go showing you the fixture. And so this is pretty much the end of this video series. I can't really, unfortunately, show you the actual machining on this part. Although this would be a very interesting video to make, but customer won't allow it, or even to say what the part is or what it does or anything. But as I said in the first video on this series, my customer felt like it'd be all right if I showed you making the fixtures, so that's what it is. And also you can see the need for those the edge stiffeners here, these parts, because there's just very little left of this fixture once it's all milled out. And to maintain some kind of stiffness, as well as the thrust from the tailstock pushing in, not bowing the fixture, and to eliminate possible vibration. And we'll see how that works out, or I will anyway, on the when you're actually machining in here. But this part requires some 5-axis positional movements as far as milling some of the faces on it. And it'll be helpful to mill both sides at once. I mean, you could do it by milling one side and flipping it over on a vertical machining center, but it would be difficult to do it that way. And it would require a lot of surface type milling to get the angles that are necessary on this part. But with this machine, because I got the B axis and the C axis here, I can angle my tool in here and get the appropriate angles on this particular part. So that's it for this video series, and thanks for watching.